We were looking for some data similar to what they have in the Tour de France.
Cycling Adventures approached us earlier this year with the possibility of being able to provide a solution to enable spectators to be more involved with the event. The solution is called the Saddleless Tracker. It took about 3 weeks for us to put the solution together. We used Microsoft Azure Internet of Things to get the information from the rider right through to being presented on the screen in front of the user.
To see the tracker at an event like this, where they disappear and you don't have television coverage, and then they come back towards the finish, you actually follow them the whole way around. Previously, you're in the dark. You've got no idea what's happening, and you're relying on CB radios, telephone communication, telling you who's in the lead or who's behind. But this hasn't only told us who's leading, who's second, who's third, it's told us heart rate, wattage data, all sorts of information that otherwise we just wouldn't have had. In cycling, the people that are real enthusiasts, they want to know heart rates, they want to know wattage output, so they can compare themselves to the best. Well, this gives them the opportunity to do that.
I've been using the tracker for 3 stages now, and it's simple. It gives spectators good vision of the competitors' statistics, which probably broadens the knowledge on the race.
We use an Android phone that supports Ant Plus to communicate with devices on the rider and on the bike. The information is then transported through the mobile network back to the Microsoft Azure Internet of Things framework.
Traditionally, I've worked on systems like this before, and you can be a few minutes behind by the time you try to process that amount of data. The Azure platform actually has given us the amazing ability to move data very quickly.
The potential for this product is huge. Using the Internet of Things and mobile devices allows a solution to be provided to spectators and riders alike that previously would have been cost prohibitive for many riders.
They really help us refine our training and our racing techniques, and also in conjunction with our teammates and our team managers and coaches. It allows us to be the best riders we can be and hopefully have a few wins.
We're looking to use this solution at the UCI World Cycling Championships to be held in Perth in 2016. We're also looking to use it at mass participation events around the world, including in Europe and North America.
My impressions of the Saddleless Tracker is that certainly a way of the future. It's something that was going to be used, and maybe not just in Australia, but worldwide, because I think it's revolutionising the way tracking has been used before.
Wow, that was nice. I'm not sure that I understood a lot because this accent is somewhat different. But here you go, lots of cycling. Good morning, you diehards, because I'm very impressed you're up. You're about after your big evening yesterday at the movie thing, whatever the movie park is called. I didn't join, I apologize, but we were at Mumu's. If you haven't been there, it's a pretty good steakhouse, so it's good fun. My name is Uli Hohmann. This is my last presentation in this wonderful auditorium, and we're going to talk about connecting devices to the Azure IoT Hub. I still am amazed that it's like school. Everybody is hiding in the back, and only very, very few are coming up forward, because we're not that many, so if you feel that you're getting lost in the back there's lots of room up here. But if you don't, it's also pretty cool, and I don't know if I've shown this picture before, but this is currently the Azure environment, as this wonderful fellow that talked about his cycling solution mentioned. And the IoT Hub is actually part of the analytics and IoT scenario set that we are supporting. It used to be part of what we called the hyperscale compute environment, but because IoT is such an important environment, we now have it running as a separate division in the Azure core environment, because it deals with complex messaging pattern, complex communication, and complex protocol issues, as well as security and other things. So we're going to talk about the Azure IoT Hub in the context of this reference architecture. How many of you have seen this reference architecture picture before? I see one hand, a couple of hands. So this is something that we have been working on for quite some time. We released it when we came up with the first IoT private previews. We shared it with our partners, and it effectively shows you what's important from a communication and integration perspective. It also shows you the elements of software we are currently building out. from the device side, from the transport side, the device and event processing, and then the presentation visualization environment. Some of it is very, very clear, like machine learning. Some of it is a little bit more flexible because one of the key characteristics of the IoT Hub and IoT Suite is that we're trying not to put you into a harness that is very, very fixed. Because IoT is such a wide field, ranging from bicycles to existing floor plan automation, to oil rigs, to mining, to all sorts of things, we really don't put a lot of constraints on there. And you will see this throughout the talk, that I'm not going to talk to you about schema a lot. I'm not going to talk to you, you need to use XML this, JSON that, or whatever the model is. At the end of the day, you can pretty much do whatever you want. We have a hook and a pluggable system for you where you can replace most of what I'm doing except for identity and security. There we will not be flexible. There we will be fairly strict and very modeled. So if you think that you're getting a software as a service piece, that's not the case. You're getting a platform with a lot of component flexibility. And that is because you have built so much stuff out there, brownfield everywhere. There is no clean IoT architecture. And that's why we're building the reference architecture to kind of reflect of how you could or should build a solution, but we're not going to put handcuffs on you. We are updating the reference architecture right now to reflect the latest and greatest from IoT Hub and IoT Suite. But this is kind of the picture that you have to visualize and remember that there is registry stores, there's provisioning, and so forth. Where did it go? Fascinating. Before I start, I want to talk a little bit about device management, explaining to you what the areas are that you need to consider when you're looking at device management. One of the feedback I gave internally a year ago, when everybody talked to me, what is the story on device management? I said, okay, can you explain to me what you mean by device management? What is it that you want to cover? Because it's a very, very broad area, and it's not something that is easily described in 2 words. So I actually use 5 or 6 slides to just walk you through what we believe are the device management challenges or opportunities. First of all, we need to provision and bootstrap a device. Bootstrapping a device can mean that we put software down there that effectively allows you to connect. It also means that I need to identify the system and I need to secure the system. I also need to do discovery. How do I discover a new device? Sometimes I'm actually going to ask Fred to go and wire the system hardwired up. But I've been working on the Singapore Smart Nation project, and they think about 1 billion devices in Singapore. 1 billion, just alone for Singapore. There is no way that you can set armies of Freds out there that manually turn on devices, configure them, and so forth. So there are efforts underway to help you with automatic discovery. So if you have not heard about all seen, all join as a standard, there are others as well, that effectively allow you as a device manufacturer or device maker to put software on your system that boots up and effectively says, hello, I am a light bulb, or I am a presentation device, or I'm a clicker. And here are the commands I can perform so that a controller on the other side can say, hey, I understand who you are, and I will manage you. Windows 10, for example, the IoT Core, is an all-seen, all-join client. So anytime you use one of those, you can publish yourself. And it's also an all-seen, all-join controller. So it offers to manage and control all-seen, all-join devices. But this is the first problem you got to solve when you think about devices and makers. The second one is you need to think through about how do I operate on devices. There's operations on single devices, obviously, but there's also operations on many, many devices. So you need to be able to query or define logical groups. Sometimes the grouping is geospatial, meaning in this room, I want all the devices to turn on at 8:15 because now the room is getting ready for production. Or I have a type of device saying all devices with firmware XYZ, I would like to do a firmware update and so forth. And of course, you need to ensure that the people that send commands are also authorized to do so. Because one of the key things that will happen is device hacking. These devices, as soon as they turn on, will be hacked, period. It's not a question of if they will be hacked, it's just a question when. Somebody will find a port scan and they will hack those things. So always thinking through who has authorization to do stuff is very, very critical. Then integrating with specialized device management services. So there's a lot of companies out there that have been using OMA as a model that actually stands for the Open Management Alliance or Open Mobile Alliance, depending on how you talk to the people, because sometimes it started off with the handheld that we now call a smartphone. When you remember, the smartphone in the original form wasn't really manageable. There were no standards. There was nothing going on that you could take a Apple, an Android, or a Windows phone and manage it. So the OMA team came together as a group of vendors and defined a standard called DM. It's a device management standard. If you have a Windows 8.1 device or higher, actually and it's not domain joined, we speak actually OMA DM to it. So the Intune service, that is the device management service for Windows phones and Android and so forth, actually speaks OMA DM to its device. And people have taken that standard and put it into cars, for example. There is a company called Red Band, for example, that is a very common application or ISV inside a car these days that speaks OMA DM. And if you wanted to manage a car, you would have to integrate with DM. And there's a couple of other things that we will talk about down the line. Device health and heartbeat, very important, obviously. We need to understand, are these things still there? And the other piece that you need to think about is, are these things still there, even if they are not connected all the time? So that's where a couple of machine learning magic comes in to help you with predicting, based upon patterns of behavior and communication sequences, is this thing still there or not? Of course, until it's really connected, you only guess, but it's an important piece to really understand what's going on. And of course, you need to be able to drive alerts based upon device state or group state, meaning a group of devices sending you this wonderful system here that's cooking me is effectively on. We can see that, but some of these pieces might not be on, and so you want to be able to get alerts from these things. I already alluded to this little DM protocol issue, so OMA DM being one of them. There is a plethora of these things, and that's the, not bane, but that's the reality of IoT. We always came up with solutions to the problem. And we, being the industry for factory floor automation, the industry for utilities, the industry for the electronics, the industry for smartphones, and everybody solved the problem using a new approach. It's very, very similar, but not the same. And so part of what we are looking into as the Azure IoT team, at the first step, we will support a device management approach that effectively allows you to use us as a channel for your device management approach. Meaning, on the device and on the service side, you will effectively get pluggable APIs where you can plug in whatever scheme you devised. Sometimes the scheme is just gzip. Deploy gzip files down to the device. We will take care of addressing the device, securing the channel, sending the data down, but you will have to look into it and think, my thing is gzip, and I would like to effectively apply these files and do what I need to do with it. Over time, we're going to add standardized DM management protocols. Lightweight M2M is one of the standards that's out there, so that's what LWM M2M stands for. It's another standard by the OMA community because they have defined a lighter weight protocol. If you look at OMA DM, as a protocol, it's fairly rich, fairly heavy, requiring quite a lot of capacity on the device. And lightweight M2M is something that doesn't require quite as much capability, but is also standardized. What does that mean? It effectively emits a series of verbs and nouns that are standardized over a protocol. Today, OMA lightweight M2M is bound to CoAP, and it's bound to UDP. Our friends from ARM, the chip manufacturer this time, they effectively have built a OMA lightweight M2M implementation on CoAP and TCP. And we have joined the lightweight M2M standards buddy to effectively decouple the lightweight M2M management protocol from the encoding protocol called CoAP and be able to say, if you want to use lightweight M2M, why not use MQTT? Or why not use AMQP? There is no reason why it is linked to CoAP. It's just emerged that way. So lightweight M2M is very high on our list of standards to support. It's certainly something that might be useful for you guys to review and look into. If you use a modern ARM chip, you will get offered the choice of using Mbed as the operating system. So it's a very small lightweight operating environment, and they have built the lightweight M2M management client into the operating system. So that's one of the benefits of using a standard, because the vendors can put the code into the chipset or into the operating system, so you don't have to worry about it, you just have to execute the commands when they come in. OPC UA. OPC is effectively the Open Processing Council. That is something that the factory floor and factory automation people use a lot. And OPC UA is a modified architecture to effectively drive modern solution. It's called the unified architecture. That's UA, or universal architecture, depending on who you talk to. And so OPC UA is also on our list. We have made a commitment to support OPC and OPC UA as part of IoT Hub. So that will come. We are looking at OMA DM because we are seeing more and more people looking at it, because devices are becoming more powerful. So that's certainly something we are reviewing. And as I said before, AllJoin is a new standard. Microsoft, Qualcomm, a whole bunch of other people. Thread is something that Google and Dropbox are driving. And there's a whole bunch of other stuff. And there's the internet, the industrial internet, so IIC, which also is driving a whole bunch of stuff. And if you thought that we all were talking to each other, we are talking, but within each of these groups. There are efforts, for example, by us to take AllJoin and have the elements of AllJoin that make sense also go into the industrial internet community, but that's certainly an early conversation and not done yet. So if you think about device management, think about provisioning and bootstrapping, identifying, securing, and so forth. How do you operate on these things? How do you identify them? How do you integrate with third parties, because they will be out there? How do you manage health and heartbeats? And what is your protocol standard down the line? Because ideally, if you start today, I would pick one of those standards. Maybe lightweight is the right thing for you. Maybe OPC UA, because then you don't have to define it yourself and you don't have to implement it yourself. But if you already have stuff, I would start to think about how do you migrate your device management approach to the right standard for your environment, whatever that might be. And so that is something that I would highly recommend. From an IoT Hub piece, we will effectively say, here are pluggable entry points, do whatever you need to do. And we will, over time, implement standards like OMA, Lightweight, M2M, and others. Again, I can't commit to a specific set yet, or a specific date, but that's certainly very high on the list. Lightweight M2M, OPC UA, and also OMA DM as part of this. I used this slide before, but just to recap, when you think about the devices, now that we have put the device management piece into context, you need to think about how do you want to drive the connectivity. You need to think about device to cloud, and most of the time it's about telemetry. You're effectively sending data down from the device up into the cloud in some kind of processing. Then cloud to device is mostly about commands or controlling the system. You can also send notifications to tell the device something has changed. Again, if it's a car, there are some really easy scenarios, like there is bad weather coming in. So you're effectively alerting the driver or the car that something is happening that it should pay attention to. Bulk uploads and downloads is another piece that you will do, because devices will, A, be sometimes only connected, not all the time. And the second thing is, you might not want to take continuous streaming because your connectivity might not be good enough, or you have to pay by each time you open a connection. Satellites are a very, very common problem with that kind of thing. We will talk about device security, cloud security, and channel security in detail. We talk about monitoring in terms of how do you look at devices, how do you understand that they are healthy, and so forth. And of course, we will talk about how do you reach and customize what you can do in order to implement your choices for whatever you already have, or pick new choices if you are starting fresh with an IoT scenario. From an IoT Hub communication perspective, we support 4 different ways for you to connect. There's a direct connection. I mentioned this in my IoT Suite talk. There is no need for you to use Microsoft's IoT agent of any software from us. You can just download the Proton C library, for example, from Apache, and directly connect over AMQP. You just put whatever key value pairs on the stream, and we will effectively go and implement, receive your commands, and drive the communication forward. If you want to use the IoT Hub as a security model, you will have to follow our security guidance with respect to how do you identify the device and how do you implement various securities. Generally, our security is implemented based upon certificates and certificate pairing, so that you have to think about how do you handle certificates on your device. The other option is you can do what we call a cloud protocol adaptation. So you effectively run directly from your device into the Azure IoT Hub. That's a very common scenario for higher-end devices, a car being a good example. MQTT is one of the protocols that we support in this area, and again, I will show you how that works. Then you have a field gateway, where you can actually take a field protocol and adapt it to the cloud protocol. In this example, we're using DDS, which is a standard protocol in the utilities and defense space. Very, very popular there, and we recommend to put it onto AMQP to get it into the cloud. Because there are always two pieces to the protocol. One is the protocol itself, meaning the physical packages, and then there's the semantics, meaning what is the protocol carrying. And you effectively replace the transport encoding and use AMQP or HTTP, and then you use the semantics to effectively feed the IoT Hub with the right information. And then last but not least is what we call gateway-assisted communication. My friend Fai Lai showed a Microsoft band talking over Bluetooth to a Windows Phone in this case, and then the Windows Phone acted as a gateway to convert the Bluetooth protocol communication into an IP conversation that the IoT Hub can understand. Because the IoT Hub does not speak anything but IP. UDP is possible, but not preferred. TCP is the preferred communication protocol, so TCP IP at the very bottom. Windows 10 does have a lot of gateway capability built in, so it supports conversion from Zigbee, Z-Wave, low-power Bluetooth, and so forth. So if you haven't looked into the IoT core, there's a lot of support for what I call near-field communication protocols to IP, so that you can put it into a higher-end processing system. The other piece that is very important to keep in mind, while I will mention IoT Core where I think it makes sense, we are not interested or focused on getting you to use Windows 10. I personally look at this as if there's opportunity for you to get to your goal faster, cheaper, or more secure, then Windows 10 IoT Core is awesome. But if you say, I already have made my bed with real-time OS, free Unix, and I want to use Raspberry Pi, I'm perfectly cool with that. So don't assume that Microsoft is a Windows shop. We are a solution shop. Whatever the right system is you want to use, both on the device side, and we will talk about the cloud side as well, we will support you. So we are shipping device libraries and SDKs for all sorts of things. I'll give you the list of platforms in a second. And we also support choices of programming. The funny thing is, C is back, because that seems to be the only language that really works everywhere and is actually lightweight enough to work in very small devices. The smallest device I've worked with had a memory possibility or memory capability of 128K for everything, for the entire system. So there is not a lot of runtime for .NET or Java to live in. So here's the list that we have currently compiled and tested. So don't view this list as, this is the only thing I can use. Because the agent, which I will talk about in a second, does actually support an open source protocol. Meaning you can just go into GitHub, download the IoT agent from the Azure IoT Hub, and just recompile it to whatever environment you want. And you can, of course, customize it. We do accept pull requests. So this is a full open source project, so you can participate in the development of the thing, help us improve it, and so forth. But these are the environments we effectively have tested so far, and that's certainly going to grow. Some of you will have seen this slide. The IoT device SDK is going to grow over time in capability. So the blue pieces, telemetry and the base library, is something that we're shipping today. The gray pieces are something that we're going to add as time progresses and before the IoT Hub goes into general availability sometime early next year. So device management library, I mentioned the protocol support that we are looking into, also the pluggable endpoints, so you can do this, gateway samples, gateway libraries, and so forth, to make it easier for you to program. But remember, you can just go AMQP or HTTP direct. We don't need this capability. This is only here to help you get to your goals faster, and not a requirement at all. A very important piece. Now, how do you connect the device to the Azure IoT Hub? Start with azure.com/IoTdev. That's the URL where this will show up. This is the IoT Developer Center, and you can effectively look at connect the device or configure your IoT Hub. And it effectively will walk you through wizards that help you with this stuff if you want one of those. Again, always, all of this is optional. If you are the hardcore developer that loves command lines, hey, have at it. We have command line interfaces, PowerShell, whatever you like, so you can go and say, no, this is a level 400, no graphical user interface allowed. Knock yourself out. But again, if you do like simplicity a bit and some help, here is a list of the current devices we support that we have played with and tested. But again, this is effectively saying just use whatever is there or start from scratch with your own library. And we will continue to look at this and keep adding things. Is ARM already on there with their... No, ARM is not yet. For example, we will look at embed devices here as well. And as my friend Failai so nicely showed, because he actually does open Visual Studio in his presentations, you just really get a piece of code based upon your language binding, and we will give you the language code up front. And then you just generate a connection string. Again, we have a tool for that too. And you replace the specific connection string for your device in the piece of code, and off you go. And that's pretty much it. Because from a connection perspective, it's a very, very simple system. And we provide you with a sample code to make that really, really easy. I assume that Failai and others have already built demonstrations in other sessions, so I'm not going to go and open Visual Studio to show this because, you know what, I think you can do this. I don't think we need to go there. Gateways. Now we have devices connected, we have an SDK downloaded. Let's assume we used Java as our language, so that's fine. Now we're saying the device cannot reach the IoT Hub directly because we're using MQTT, or we are using DDS as a local protocol. So now we have two choices. And there will be a field gateway before we go release the IoT Hub. And the field gateway is called that because it's deployed in the field, quote unquote. A very common use case is you have a factory, a plant, where you effectively deploy devices, and then you deploy a field gateway to protect the plant, and all the devices in that specific plant actually connect to the field gateway. They don't connect directly to the cloud. So a lot of common security scenarios that I've heard from plant managers is they don't want their factory machines to connect directly to the internet. They want it to go through a gateway so that they can control what's coming in, what's going out, when are the patches coming in, when the updates, and so forth, rather than going directly to the device. There is a little loophole that manufacturers are starting to exploit. It's called cellular connectivity. So people are putting SIM cards into the machines directly so that they can call out from the machine to whatever their cloud is and manage the machine directly. So if you are a plant manager, ask the machine manufacturer, are you putting a SIM card in there? And if you do, can I please have that so that I can connect my own or control it at least? Because the field gateway is a kind of put ad absurdum if you have the machine directly connect because it's getting managed by the device manufacturer. So currently we're thinking 3 roles for the field gateway. Communication assistance. So how do you effectively secure the data flow from the cloud to the edge of the plant and then into the plant? Protocol translation, I mentioned OPC or DDS as protocols that are more local area network protocols. Data buffering, so again, you can have all the devices send data continuously to the field gateway and then have the field gateway once in a while do a bulk upload so that you don't have to be continuously connected. Again, manage connectivity cost. There is a lot of requests for what's called data filtering. So think about the scenario where you have 100 machines in your plant and each of the machines sends a "I'm healthy" every second. I'm healthy, I'm healthy, I'm healthy. Even a cloud at some point in time gets bored by getting the same messages from 100 machines every second. So you effectively say, I want to give an update every 10 seconds or every 30 seconds, and so you filter locally what's going on, but you effectively send a message that said every 30 seconds, let's say, all of my machines said healthy, and that way, the machine learning algorithms that look at anomaly detection understand that throughout the time of the last send to the new send, no anomalies have occurred, so that they can continue monitoring your plant. So there's a couple of examples we have shipped where we show you how to do data filtering and still get anomaly detection and other machine learning benefits that we've talked about in the IoT suite session. And then the gateway is also going to be very much like a Windows update service where you can push the update into the plant with a certain set of parameters. And then the field gateway is the one that applies the update. It's the cloud simply sends an update for the plant, and then the field gateway provides the update. We haven't really released the field gateway yet into preview, so that's a coming attraction. Most enterprise scenarios that I've seen will require a field gateway because people do not want their systems, plants, oil rigs, whatever they are, to be directly connected. So stay tuned for that piece of software. Our commitment is it starts with Windows Server, but we are looking into ways to provide it also as a Linux version. So if you don't want Windows in your environment at all, you're a religious person, we will make sure that the Linux religion that you now adhere to will also be served at your leisure. So our commitment here is to make this integrate with whatever you want it to be, not whatever we think. And again, we are talking to the various gateway providers that are providing hardware gateways to also make our software as part of their gateway deployments. I talked a little bit about the cloud gateway already, but the cloud gateway is effectively enabling you to build protocols directly on IoT Hub. And what we have done here is we implemented, or we took the IoT Hub core, which is a multiplexing, highly scalable device or software that takes a lot of incoming connections and manages outflow. So if you look at Event Hub, Service Bus, or now IoT Hub, they all are doing multiplexing of connections, lots of them. And we took that software core and externalized it as a protocol gateway. And then we effectively are building protocol gateway libraries on top. In this case, the first implementation we're going to do is MQTT. To be precise, it's MQTT 3.11. So if you are an MQTT person and you have MQTT 3, the gateway will not work out of the box, but it's going to be open sourced, and so you can start to adapt whatever you need to adapt there. And why are people using gateways? A, because they made a protocol choice that we currently don't support. So there is a continuous conversation in the IoT team. How many protocols do we want to support? How many do we need to support? MQTT is very high on the list of putting it into the standard. I mentioned this before. There is a very lively debate going on. Is MQTT a cloud protocol or not? Our assessment is the current version is optimized for client connectivity and client points of view, not for the cloud. And so we are working with the OASIS working group and IBM and so forth to introduce new capabilities and fixes for cloud optimization of MQTT, because we believe MQTT is a good protocol, but it needs some optimization to work well with the cloud. And so there is a proposal for MQTT 4 on its way. and it's supported by us, and we're working with the other players in that market. So if you are interested in gateways because you have implemented your own protocol, the MQTT gateway code is the way to go. So take that, read what we have done, and then apply it yourself for whatever your protocol is. I have a project going on in Southeast Asia somewhere for XMPP, because that's a protocol that some people use for camera automation. So they're managing security cameras and stuff like that. Some people are looking at CoAP as a protocol. Some are looking at DDS as a protocol. So there's a lot of people looking at how to use this protocol gateway foundation to build their own highly scalable protocol. Don't build it in VM roles, because you will have to do a lot of work in between. The other piece that a gateway allows you to do is, of course, putting functions into the system that you want to do certain custom attributes. We use here some example: authentication, encryption, decryption, compression, decompression. I'm working with a customer that uses MQTT, but they mixed 3.0 and 3.11. So they freely mix the verbs. They also use Google protobufs as an encoding library, and they also put logic into the protobufs sequences. So before I can build it into the Azure cloud, I have to rip it apart and make it a clean AMQP set of messages that I can run. So this is effectively an interception point for those protocols. Why the gateway? Again, the reason is we cannot build all the protocols in the world ourselves, because you just have done too many of those variations. You have been creative, which is a good thing. And the other piece is there is a reason to be interjecting custom code. And so we really want to help you build a scalable protocol approach that is nicely integrated with the IoT hub. And then .NET is something that we found, quote unquote, and we found it very useful to effectively build the MQTT foundation for it, or using it. Now, we've talked about gateways, we've talked about the device. Now let's talk a little bit about the IoT hub. The IoT suite is just the end-to-end system from a monitoring and application perspective, but we are going to focus on the IoT hub today. The IoT hub, my friends normally use builds. I don't like builds because I always get confused. When do I stop clicking? Because I always go one too far and then the picture is gone. So excuse for the busyness of the slide. But let's start at the top left. We are differentiating 3 or 4 different types of communication. First, you have the device sending something to the cloud. That's a very common endpoint, and that's something that we manage and multiplex. So our IoT client, for example, is a multiplexing client. So you can have multiple application endpoints sending messages over a single channel, which is a very useful thing. And the IoT hub, the device to cloud endpoint, understands demultiplexing. So it understands how, oh, this is actually an overloaded communication channel with multiple device endpoints, and effectively runs it that way. Then you have the cloud to device queue endpoint. And this is a queue for the reason that we don't believe that devices will always be connected or will always be reliably connected. So what we are effectively offering, both from an IoT hub perspective or any other application that want to send a command to a client or device, we queue that. And I mentioned it in my IoT suite talk. It's effectively a pattern, what we call a mailbox pattern. So we effectively create a mailbox per device, and so it's implemented as a queue. And since we're using Event Hub underneath the covers, it is effectively a publish and subscribe queue, and we effectively manage the subscription to the device automatically. You can subscribe to device events if you're authorized to do so. And we keep the messages for 30 days, and we effectively delete it automatically by then. But you have the usual wonderful queue problems, dead letter queues, and all these other things, so that doesn't go away. And we will effectively give you tool chains or management tools to manage all these issues that are very common in queuing. So if you're a BizTalk person or a service bus person or TIBCO, you know what I'm talking about. If not, you will learn. It's what we all do. And then on the other side, to the right side, we have effectively the cloud services communicating via the IoT hub with the device world. And again, the device to cloud receive endpoint and the cloud to device send endpoint. Think of this as message box entries. I'm sending a message into the thing, I'm receiving a message, and that's how that works. We are building a specific management, feedback, and monitoring endpoint so that you can build a application logic. We will build one on Power BI. So we effectively show you a dashboard of all the devices connected and stuff like that. But if you say to us, I already have one at home, I'm using, I have no idea, HP products to manage all my things, and I want to manage my devices the same way, we effectively feed those information via REST-based APIs into you, and you can just sign up. Device identity management we will talk a little bit more about, and device provisioning as well. And then we, of course, have an IoT management suite or environment where you can manage the hub itself, because it is a product. So think of this as a mailbox. That's the best way of really visualizing it. And you send messages into the mailbox, devices pick it up, and the devices send messages into the mailbox and you pick it up, or multiple people pick it up, because it is a pub-sub pattern at the end of the day. Device to cloud. Let's go a little bit deeper. Interface today is AMQP and HTTPS. Why is there no AMQP/S in there? Because AMQP has been designed from the beginning to be only encrypted. There is no non-secure AMQP communication. So it always uses TLS underneath the covers. And again, we are implementing a device-side endpoint and a service-side endpoint. And I showed you already the device and service SDKs that we support. The only thing that we will add to the SDKs, or it's already implemented, is that if you use our SDK, you are transport independent, because we will do the abstraction against HTTP or AMQP, or down the line MQTT and so forth. So if you write to our API, you don't have to worry about which protocol is being used. If you do care about protocols, then you have to use the specific protocol APIs. The whole thing is compatible with event hubs. As I said to you before, the IoT hub team used to be part of the event hub team, and they were responsible for Service Bus, Event Hub, and IoT Hub. But we believe IoT is such a big deal that we created a specific team that now worries about IoT Hub. But underneath the covers, we still use the Event Hub technology, and of course, we keep synchronizing the code, because IoT Hub really builds around Event Hub. They're abstracting the Event Hub, and we will add new verbs for it. So today we do AMQP and HTTP, really mailbox kind of messaging protocols, but we are looking into other things like streaming. How do I stream if I have a high-speed connection and I want to stream events? How do I do this? Or if I do video, so I'm a security camera and I'm actually streaming the video into the cloud. How do I deal with that? Event hubs really don't like that kind of thing. And so we are looking into expanding the scope of IoT Hub with new nouns and verbs, which effectively will cover more scenarios. But from a pure messaging, eventing perspective, it is Event Hub with new verbs and capabilities. Because Event Hub, as you guys know, is ingest only, whereas IoT Hub is command and control plus ingest. And then device to cloud. Again, we are clocking very much like our friends from the Event Hub, since we're based on their same technologies. I mentioned it in some private briefings. The Halo guys gave us the benchmark, what we have to do in order to meet their requirements and not have them build their own, which is something that Microsoft people also do. If you don't meet what I need, I will build my own, which is not really helpful always, but it is what it is. And so the Halo team came to us and said, we need 1 million events per second. The event size is 1K, which is the reason why we support 1 million events or 1 gigabit per second. And we will increase that number as fast as we can, because we already are processing about 1.8 trillion events per month. And it will only grow, because the eventing infrastructure is something that we use internally heavily. So think of this as the next generation SOA. When you do microservices and other things, eventing is part of your life. and that will keep growing. And so this is the pattern we effectively implement. I already mentioned connection multiplexing. We do per device authentication, which is one thing that the Event Hub doesn't do. The Event Hub is effectively not an autonomous, but a shared secret kind of connection, and it doesn't really care if it's Fred or Hubert that sends it. In our case, for IoT, we might not care which device it sends it, but most of the time you do care. And you want a clear identity that is this guy and this device sending it, and so we effectively create a per-device authentication channel. Identity in the IoT Hub is a key thing, and that's where we will not be very flexible. We will effectively provide you with a provisioning orchestration environment. If you have looked at Azure App Services, you may have found a thing called Logic Apps. We will effectively use Logic Apps. We built ourselves Logic Apps to effectively represent the workflow of how you provision a device. And over time, we will enable you to effectively build your own workflows. We will give you an API underneath the covers to say the device provisioning has these requirements. This is what you have to give us. How you give it to us, we don't really care. Logic Apps is just a very convenient way of doing it. And you effectively drive the registry of the device in a single identity system. And we are calling that the identity registry. The goal is to integrate it with AAD, the Azure Active Directory, but the AAD team is somewhat busy right now, and so we started off with our own identity registry, but we are going to work with the AAD team to make it a single identity system for everything Azure. And again, we are looking at bringing, or we are requiring today that you're using certificates. So you create a pair of certificates effectively, and the IoT Hub is then the certificate manager. So your device will say, hey, I'm booting up. I'm going to give you my certificate that I got built in, and then I will effectively override it because I don't trust that you haven't been tampered with. So if you are a certificate person, you know how this workflow works. If you don't, spend time on it because it's a really important workflow. And if you cannot change certificates dynamically, that also exists. We are looking into supporting pre-shared keys. The problem with pre-shared keys, if you're a security person, you're already going, no pre-shared keys, because once they are hacked, all of the devices are compromised. And since they're pre-shared and mostly in firmware, you can't change them. So don't rely on pre-shared keys if you can. If you cannot, you have no choice. But really try and get a TPM-like thing or a cryptographic store on your device. The ARM guys have a nice chipset for you. I think it's the M7 that supports cryptographic keys, but I'm sure that will go into all of the systems over time. So please, please, please make it updatable. Then the IoT Hub, I mentioned the reference architecture in the beginning. We will talk about an identity store. We call it now the identity registry. Then we talk about the device registry. What is the device registry? Identity is something that is not flexible. You have to use ours, because otherwise we won't manage your security and we don't know who you are. The device registry is what I call the last known good store, meaning the last state of the system or the devices that I connected is stored in that environment. The reference architecture, I think right now uses DocumentDB, which is a JSON-based NoSQL store, but it will show you how to replace it with whatever store you like, MongoDB or SQL or something else, because we are not building a device registry store right now as part of the product. We effectively give you a reference implementation. You can use it. It works just fine. And it has a web portal, but we effectively are saying, look, devices are so diverse, there's so much stuff, and you might have made choices. Maybe you want it on a mainframe in DB2. I don't want to stand in your way there and effectively use what you need. And the third store that's not here is the time series store. So one of the key things that you do with devices is, yes, you have the snapshot of what was last. But then ideally, you also have a history of what has this thing done over time. And you effectively want a time series store, OpenTSDB or something like that, to effectively support it. And so there are historians out there from companies like Schlumberger or Rockwell, or you use an open source implementation like OpenTSDB, time series database, on top of HBase, on top of HDFS. So you effectively have a Hadoop-based solution, but don't store the time series in the device registry store. So you will have 3 stores: identity, last known state, and the time series store, so that you run analytics and applications against the time series store, not against the device registry. Think the device registry more like, what's going on? Is there anything red? Is there anything flashing? Accessing IoT Hub from cloud components. So we effectively enable you to talk to devices through IoT Hub, and you have to effectively ask us for permission. And we give you authorization policy, where you can say Event Hub or Service Bus or Stream Analytics or Machine Learning or your custom code. They are enabled or authorized to send commands to devices. And that's effectively the way we do this. So you can connect to a device, the service connect, register read and registry write. So remember the identity registry I mentioned before? This is what enables you to do writing into that thing or not. And the IoT Hub management tool effectively allows you to set those policies. And of course, there's command line interfaces and PowerShell for the people that don't accept graphical user interfaces, which is fine. Sample scenario, again, I think we walked through most of it already, but think about this way. The simulated wind turbine emits telemetry every second. It's a state machine. It's started, stopping, stopped, because it's fairly long running. I don't know if you've seen one of these wind turbines. They are fairly massive, so they don't stop on a dime. And so what's happening is we are provisioning the device registers query devices and track provisioning. We use the device identity and key stored in the IoT Hub, in the identity registry store. The device emits the telemetry. And so in this case, we built an event processor. So there is a template called event processing, event hosts, that we effectively have implemented here as a sample. So this wind turbine sample will come out as part of an IoT Hub SDK to show you how it's done. And I love this gray on white background, where you can almost not read it. It's actually not that bad for you. For me, it's almost unreadable here, saying, oh my God, hopefully these guys can read it. So the event processor is effectively an application that uses events to process something. The default event processor we use is Azure Stream Analytics. So when you use anything, we feed the event stream through the Stream Analytics solution. If you don't want to use ours, you can use Spark, Storm, and so forth. And that's really the way you build this. The portal that's mentioned here is the open source portal that we will effectively ship as part of the reference architecture. When we started the IoT effort, we built a product called ISS. I don't know if you remember that. ISS was called the Intelligent System Services. And their approach, the team's approach, was, I think, very ambitious, way more ambitious than we are today, because we have learned a lot. They wanted to build a software as a service solution, a SaaS offering. And they built a portal and was super sexy. It was super easy to connect devices and everything else. Problem is, every partner that we work with, every customer we work with, we like your portal, was the polite way of starting. And then they said, but we would like these 5 things different. Unfortunately, we never found the 5 things consistently, and so we said we give up. And so we effectively said we're building a reference implementation, which will work out of the box, and we will keep updating it and so forth, but we will open source it. So that you can, instead of you starting over, which is what our partners did, they said, we're going to use ISS for what it's good, but we are going to build our entirely different portal. We said, don't do that. Use 70% of our code, whatever it is, but don't build a completely new thing, because that doesn't really help you or us. So that's what this portal is about. If you go back to the reference architecture slide, this is what this is all about. Consuming device to cloud events, so you can code against Service Bus message APIs, as I mentioned before. There are some interesting deduplication pieces that Service Bus allows you to do. You can create Service Bus queues and topics. So the IoT Hub sends events in, you effectively persist it in a Service Bus queue, and you have worker processes driving it forward. The hot path, as I mentioned before, is generally Azure Stream Analytics that we use. It's also used sometimes to just say, I'm taking an event and pushing it into storage. You can do that without using Stream Analytics, but a lot of people use Stream Analytics to clean up events, to enrich them, and to do certain things before they persist them. Time series data or whatever those might be, and as said before, Storm and Spark, and of course, custom code. And then run batches. You can just dump them into Blob, and then you can run batches using your whatever favorite loading tool is, Azure Data Factory and other things, to take the data from the system and process and consume it. A common pattern is file uploads. IoT Hub today does not support direct file upload. So you as a device guy have to say, I want to put a blob up. And you then have to figure out a way how to do that. If you're using HTTP, really easy. If you're using MQTT, AMQP, CoAP, other things, not so much, because they are not understand what a file is, whereas HTTP does. So HTTP has some benefits, despite it being a fairly inefficient protocol. But it is certainly something that can be implemented fairly easily. There are example implementations of file upload on AMQP. So you just chunk certain binaries over. And the way we work it is you effectively put the blob up, and then you send a message to IoT Hub, I put a blob here, and send the link. And the same thing is true for the other side, which we come to in a second, cloud to device. Think of this simply as a reverse with one key piece or two pieces. One, we support at least one semantics. We don't do guaranteed delivery because that's way too heavy. Remember, our goal is to be super scalable and fast. So 1 million events per second, doing guaranteed delivery is really hard. But it's durable. We do device acknowledgement receipts, all these other things, so that you get a lot of semantics that you're used to when you are an ESB guy. The other piece that we put automatically in there is time to live and delivery receipts in terms of acknowledgement. I got the message, I didn't get the message. Time to live is really important. Let's assume you have a car, you have a key fob, and you go into the shopping mall and you send a command from the key fob to the cloud that says, close my car or open my car, depending I'm coming out. And for some reason, the cloud cannot reach it in time, but you move on because you trust that this thing will work. If the command, let's say open the door, comes in, or close the door, let's do the open door command, comes in when you're already gone, then all of a sudden, boop, the car opens the doors and you are effectively in insecure state. And so time to live is something that we will put on every message by default. You can customize it, obviously, but it's something that you really need to think about. How long do you want that command to hang out? If the device all of a sudden connects, it gets the commands, do you want it to be executed no matter what? Or if the command, let's say the device is off and you want it every 5 minutes, put a 5-minute delivery time on it, and if it doesn't get it, put it into the dead letter queue, write an alert effectively that the system didn't pick, or the device didn't pick it up, but make sure that there's a time to live on there. It's a very, very important piece to effectively go from there. And again, this is a queuing-based system. Call it mailbox, call it queuing, doesn't really matter. So a lot of the same semantics apply. Dead letter queues, couldn't deliver, retries, all that stuff, which we will do. So there are standard defaults in there saying, hey, we will try 5 times, and if I can't deliver 5 times, it goes into the dead letter queue. So if you haven't looked into queuing a lot, get used to it, because underneath the covers, the IoT Hub is basically a queuing system. Again, sample scenario, sends commands to individual turbines, and the accept, stop, and start commands, but those are long-running. And again, the key thing is that the client, the device, understands that it's long-running. So it actually has a state transition that goes through stopping and to stop, and starting and to start, not just start and stop. Because you want to acknowledge that you got the stop command, and then you send to the cloud, hey, I'm stopping right now. And the cloud can then say, stopping can take normally 30 seconds or a minute or 5, whatever, so that the anomaly detection system can say, okay, if it stops within the 5 minutes I allotted, I'm good. If it's not, and it's still in the stopping state, I can start to do something about it and saying, hey, technician, something is wrong, because the thingy is still stopping. Wouldn't it be nice if some of the operating systems would tell you that actually I am shutting down, instead of going black on you and saying, and you don't know what's going on. But that would be a nice thing to do. Event processor, again, is that piece on the right side, on top, where effectively we take events from the client and feed it so that you can process it. Nothing magic here, and you see the portal now with a sexy graphic. The default is a web application and Power BI. There's a couple of optimizations you can drive with Service Bus and so forth to parallelize the work across multiple IoT Hub instances. IoT, the publish file is the same thing, just reverse, so that you can drive it from there. Let's talk a little bit more about security. Constrained resources, which is a #1 thing. I mentioned the pre-shared keys. Geographic distribution and off-premise deployments. I talked to a bunch of people that are in the mining business. Yeah, those are very, very tough, although they are not easily to get to, so that's not that bad. Low or no physical security. If you deploy smart things in here, everybody can touch them. The scale is driving everybody crazy. So one of the reasons why the AAD conversations are a bit later is the Active Directory people looked at the numbers and said, holy, and said, we need to work on this because scale is a really problem. And of course, a lot of devices are analog today, not digital. And so lots of people can go through the analog system and start to really hurt you. So what we're doing is we are working on 2 principles with and implementing a couple of capabilities. I mentioned it before, the service-assisted communication. Generally speaking, we are trying not to rely on IPv6 or VPNs or other things, which are fine augmentation tools. But from our perspective, a device cannot be reached from the cloud. I cannot talk to you directly. What I do as a device, I wake up once in a while, or I'm continuously awake, and I open the communication channel to the cloud. And then I will grab commands and pull them down. Why is that important? Think about your home router. No home router today actually blocks outgoing communication. By default, they block incoming communication, which is awesome because they are much, much more secure by a very simple trick. And the cloud is the one that actually defends you, meaning the cloud is the one that does all the basic, or the work around DDoS, firewalling, all that other stuff, so that a simple device doesn't have to do it. Now you're asking yourself, how do I wake up a device? What do I do? If I don't am always on and always connected, what do I do? Take the car guys. So if you have a GM car with OnStar in it, there is a modem already in it. And the modem goes to sleep about 20 minutes after the car is turned off. So if you park the car overnight, it actually is dead. It's not going to communicate or anything. What it does do is, for some reason, there is always a little SMS capability. So what device manufacturers or car manufacturers do is they send an SMS. The SMS wakes up the modem. The modem completely ignores the SMS message, by the way. They don't read it. They simply say, somebody tickled me. And they go to the cloud and to their trusted endpoint and grab the messages. So if you're building a wake-up system, whatever it is, web services and other things, do not read the message. Simply say, somebody tickled me. And go to MAMA, meaning the secured endpoint, and go there. Do not trust anything that comes from some crazy channel like SMS or so forth. Because our hacker friends are very, very, very good. And so they will find that piece. Device monitoring and updates, we already talked about that in terms of using machine learning to really figure out, are these devices still there? Are they updated? Are they running? And then from a capability side, we are really looking at hyperscale messaging, reliability, and so forth per device, and per device authentication. I mentioned the secure channel already. And then secure ingestion of telemetry, because we also need to know it's you sending the data. It's not some random thing. And then the other piece we are looking into is the Azure Security Center, which I hope some of you have seen, or most of you, has some very fancy capabilities to determine, based upon patterns and data, have you been breached or not? we are looking at how can we take that kind of capability to provide device security. And certainly something to do. Principles in-depth defense. So we are working together with the vendors of devices as well as the solution people. Because as always, it's not something that we can do alone. Because if you are insecure on your own device environment, not much we can do except we secure the channel and we secure the endpoints, but that's about it. So we urge you to leverage the capabilities we have or bring your own capabilities as part of your deployments. Service-side communication, we already talked about register read, service connect, device connect, the identity registry, key rolling, that's effectively the certificate management that I mentioned before, and then the physical device provisioning, which is, again, something we're going to standardize using some standardized protocol over time. Advanced topics, I think we mentioned through all of this already, transparent versus opaque, pull versus push, yeah, normal messaging stuff. And then custom authentication is something that you can do. The only ask we have is do not put a gateway, a token gateway in front of IoT Hub. If you do, use the protocol gateway capability, the cloud gateway that I mentioned before. And then you can use tokens with the IoT Hub. This is a documented pattern where you can manage your own authentication scheme if you don't want to use ours. And monitoring device connectivity, we already talked about that. And again, this is currently implemented using Stream Analytics. If you don't like that, you can remove ours and reuse Storm, Spark, whatever you like. And that's about it, yes. So, I walked you through a heck of a lot of stuff. I didn't bother to show you some Visual Studio thing because I know that you guys know Visual Studio. You can read code and other things. My main aim was to really walk you through the various scenarios and capabilities and also give you viewpoints of what you need to think about. There is another series of guidance we are working on is how do you design? What are the lessons learned? I was actually thinking about doing that session instead of this one, but the team asked me to talk about IoT Hub, so I did. But there is a lot of guidance that we have learned over the last 2 years, 3 years, working on high-scale IoT scenarios of what not to do. So one principle, for example, is changes in the device are hard and very, very expensive. As soon as they are deployed, think of devices as read-only, pretty much. And changes in the cloud are much easier. So if you can move as much as possible your logic for your IoT solution into the cloud, much, much easier to change. If you say, no, I have a super smart device and I want it to be that way, fair enough, but really balance the capabilities and stuff like that. Security, do use a chip that has a cryptographic key capability. That's a really big deal. And I personally think don't open ports is a good idea. Only send, don't open inbound ports, only use outbound ports. That way, your security model is very, very simple. With that, I have 4 minutes left. Invite questions, or if you don't want to get to the microphone, I'm going to hang out a bit so that you guys can ask more detailed questions. And I really want to thank you guys for your hospitality so far. I enjoy Australia. This is my 6th trip, I think, in 20 years. So not bad from a Redmond kind of guy. And I will look forward to hearing more about your solutions that you're building and hope to see you soon again. Thank you very much, guys. Questions? Anybody? Nobody. You guys are still hungover. Okay. I get that.